All right, so in this lesson, we are going to solve inequalities. Remember that inequalities are not equations. Equations have equal signs. Inequalities have things such as less than or greater than. Remember, it just depends which way you read it. You could also have greater, equal, or less, or less and or equal. So let's start off pretty easy. Let's graph the solutions to one variable, very simple inequalities. So remember that before we had x equals 4. Remember, this is an equation. This is an equation, this first one. Remember that we put a dot right here to show that x was 4. Well, in this example number 2, it says x is larger than 4. So I can't put a dot there. But I can put a dot at the 5. I can put a dot at the 6. I can put a dot at the 7. I can keep going. But I can also put a dot at 5.5 because 5.5 is bigger than 4. I could put it at 6.1 because 6.1 is greater than 4. So I can basically keep putting these dots. Don't forget that also 4 points anything would work, right? So I can put all these dots. The question is, where do the dots stop? Where do the points stop? Well, the question is, can x be 4? X cannot be 4 because it has to be greater than 4. So we put an open circle around the 4. Just to show that it can't get to 4. It can get super close to 4. It can get infinitely closer to 4. But then we're just going to shade these instead of drawing them in because it can keep on going forever. Like a million is larger than 4, is greater than 4. So let's try this next one. We have x is less than 4. Can it be 4? No. So I'm going to put an open circle there. But it can be like 3, 2, 1, 0, negative 100, negative 1 million. It can be negative 4.3. It can be negative 4.0000001. So remember, I'm going to, instead of drawing all those dots individually, like this, instead of doing that, I'm just going to attempt to symbolize an infinite amount of dots. So x is less than or equal to 4. So can x be 4? If x can be, remember this is greater. Oh, that is not greater. X is less than. Or the little line, equal. So can x be 4? Yeah, because it can be equal. But x can be 4 or it can be less than 4. So any number over here, any dot over here, and going on forever. Okay, let's look at this next one. X is greater than or equal to 5. Well, can x be 5? Yes, so I'm going to fill it in. Can x be greater than 5 or any number? Oh, x has to be any number also greater than 5. So instead of drawing all these dots over and over, remember I'm just going to show that all the dots are over here and they keep going forever. X is less than 6. Ooh, I wonder where that came from. Kind of curious. It doesn't matter, I guess. X is less than 4. X is less than 6. Can x be 6? No. But x can be less than 6. So it can be 5, it can be 4, it can be this one, it can be this one. Remember, we just draw all the dots at once. That's really going to bother me. I'm going to see if I can undo that. Nope, doesn't look like it, so I'm just going to sit with it. I'll fix it later. Okay, so x is greater than negative 7. Now remember, with the negative 7, if we go left, it's negative 8, negative 9, negative 10. It keeps going on forever. But x can be greater. Can x be negative 7? No. But it can be any number to the right of negative 7. Okay? X is less than or equal to negative 8. So negative 8, negative 9, negative 10. That would put negative 7 over here. So it's less. Less is to the left. So can x be negative 8? Yes, because it can be equal to. And then it's going to have to be less. Any number over here. Now let's solve some inequalities the same way, or almost the same way we did equations. So 4 times a number is less than 28, or a number times 4. So we had x multiplied by 4, and we got 28. Remember, if we go this way, we have to undo it by going backwards and using inverse operations. So we divide each side by 4. 4 divided by 4 is 1. X is less than 28 divided by 4 is 7. So x is less than 7. So I go to my number line, 7. I put an 8 and a 6 to show that I know what I'm doing. And I put, can x be 7? No. So I leave it open, and it can be any number to the left, less than 7. Remember, it keeps going on forever. So in this problem, this example number 10, we have a fraction. Remember how in the equations, whenever we had a fraction, we can multiply the entire, we would multiply the entire equation by the denominator. We would do the same thing here. So we're going to multiply each side by the denominator, which is 4. So multiply both sides of the inequality times 4. So 4 times 3/4 if you want. 4 times 3 is 12. 1 times 4 is 4. 12 over 4 is 3. If you need to just turn it into decimal form, that's fine too. Remember that. Positive times a negative is a negative. 4 times 1 is 4. Now let's not forget our sign. One common mistake that people do is they forget about it and then put an equal sign at the end. 5 times 4 is 20. Now we can do like we normally do. X times 3 minus 4, and we got to something to do with 20. So we did all that, and we got something greater than or equal to 20. That looks a little weird, but it'll do. So the last thing we did was minus 4, so we need to add 4. Plus 4, plus 4, so we get 3. X is greater than or equal to 24. And then we divide each side by 3, because that's the opposite of times 3, or multiplying by 3. X is greater than or equal to 8. So let's put an 8 here, 9, 7. So can x be 8? Yes. So I'm going to put a dot. And it can also be any number larger, so anything over here. Okay, so this looks like a pretty simple one. We have x, we multiplied it by negative 3, and we added 5. And we got something greater than 17. So we went this way, we had to go backwards. So instead of plus 5, minus 5. Minus 5. So we get negative 3. X is larger than 17 minus 5 is 12. Now, here's the only difference besides, that we don't have an equal sign, basically, between this and equations. You see how we multiplied by negative 3? That means we need to divide, of course, by negative 3, which is fine. That's what you would have done before. But you see how this is divide by negative 3? That means we have to flip this sign right here. So that becomes 1. We get 1x. But see how the mouth was facing the left? We need to face the right. We flip it because we divided by a negative 3. If you ever multiply or divide, I'm going to say this again. If you ever multiply or divide when you're moving backwards, if you ever multiply or divide when you're undoing, going backwards, by a negative, like this -3, then you're going to have to flip this sign. So positive divided by negative is a negative, and we have 4. So I'll put -4, -5, -6. Okay, so can x be -4? No, so I'm going to leave it open. But x can be a number less than -4, so anything over here. Okay, we see another fraction, so let's multiply by 2. Oops, let's try that like this. Okay, so you see how you're multiplying this positive times a negative? Well, it's not gonna, we don't change anything. We don't change anything because we're not going backwards. We're not going backwards. When you're moving backwards, that's when you flip the sign. So 2 times 5, or positive times a negative is a negative. 2 times 5 is 10. 10 over 1 times 2 is 2. So 10 over 2 is 5. And then a positive times a negative, I forgot the x. And then a positive times a negative is a negative. 2 times 30 is 60. And then it should be less than or equal to 2 times -10 is -20. Not too bad. So let's do this. So times -5 minus 60, and then we got something less than or equal to -20. So let's go backwards. So instead of -60, we should do +60. -5x is less than or equal to +40. Now, we multiplied by -5 here, so we're going to have to divide by -5. Divide by -5. But remember, when we're moving backwards, when we're undoing, when we're using inverse operations, if you multiply or divide by a negative, we're going to flip. So negative over negative is +1. That's why we did it. And we have to flip this sign, like I said. And a positive over a negative is a negative. 40 divided by 5 is 8. All right, we're almost done. Let's just graph it. -8, -9, and that makes this -7. So x is greater than or equal to -8. Can x be -8? Yes, because it can be equal. But it can also be any number greater. So any of these dots over here. And that is it. Thank you.